Yesterday we started chapter 6 looking at expanding and condensing exponential expressions. Today we are going to specifically look at the patterns that we found through expanding and then simplifying. The first is considered the product rule. This occurs when you are multiplying two exponential terms together that have the same base. So exponents of like bases, as we said yesterday, are added together. This becomes the total number of factors of your base. So in this first example, 8 to the 5th times 8 to the 3rd, our base is 8, so we are adding these exponents together. So this becomes 8 to the 8th power, meaning we have 8 total factors of 8. In the second example, we have 9 factors of y times 1 factor of y, so that becomes 10 total factors of y. In the third example, we have 4 factors of a times 3 factors of a times 10 factors of a, so we must add all of those exponents together to give us a total of 17 factors of a, which is just a to the 17th. In the fourth example, we're going to first focus on our base of x. So we have 4 factors of x and 5 factors of x. So we know that's a total of 9 factors of x. But then we are multiplying our coefficients. So 2 times 3, and that just gives us 6. So our total quantity is 6 times x to the 9th power. The next one we looked at was I did forget to unpause earlier, so if I duplicated any of this, feel free to fast forward. Going over the power rule, as we said yesterday, all of the inner exponents are multiplied by the outer exponent, even the invisible one. When I talk about inner exponents, I mean the exponents inside parentheses, and the outer exponent is the exponent outside of the parentheses. So in this first example, we are multiplying the exponents 4 and 3, making this 7 to the 12th power. Yesterday, we looked at expanding this originally, so 7 to the 4th to the 3rd power would be 3 factors of 7 to the 4th. And as you can see, that is 12 total factors of 7. In the second example, x to the 5th to the 2nd power would become x to the 5 times 2, giving us 10 total factors of x. In the third example, this negative 10 does have the invisible exponent of 1, so we do have to multiply that by the outer exponent of 2, making this negative 10 to the 2nd, and then x to the 12th. We can simplify that if we want. Negative 10 squared is positive 100, x to the 12th. And then in our last example, the 1/3 has an exponent of 1, the x has an exponent of 1, and the y factor has an exponent of 3. So each of those exponents gets multiplied by 2, making it 1/3 to the 2nd power times x to the 2nd power times y to the 6th power. We can simplify that if we want, since 1/3 to the 2nd is 1/9, so it becomes 1/9 x squared y to the 6th. Lastly, we have our quotient rule, and that's when we are dividing factors that are like bases, so their exponents are subtracted from one another. As a reminder, that is the opposite effect of the product rule. Since division and multiplication are opposite, so subtraction and addition are opposite. A reminder, this occurs if we were to expand this expression without exponents, so that's 5 factors of 2 divided by 3 factors of 2. And the reason these exponents are subtracted is because our pairs of 2 divide to 1, essentially decreasing the number of factors total. So we are left with 2 factors of 2, making this 2 squared, which, as you can see, 5 minus 3 does equal 2. So in this first example, our base is 2, and this would become 2 to the 11 minus 6, so 2 to the 5th power. Really, that just means 6 of the pairs of factors of 2 will divide out, so you're left with 5 factors of 2. In the second example, our base is negative 4. This becomes negative 4 to the 7 minus 4, making it negative 4 to the 3rd power. In the third example, our base is x. So this is x to the 5 minus 3, making it x to the 2nd power. In the fourth example, our base is y. So this is y to the 11 minus 5. And as we said yesterday, we can divide the coefficients, or in this case, simplify, since it is a number less than 1. So we could write this as a fraction. 3/12 is 1/4, y to the 6th, or we could write it as a decimal. 1/4 is 0.25, y to the 6th. And in the last example, we do have 3 different bases. So we do have to make sure we are subtracting the exponents of like bases. So this becomes, well, I'll start with the coefficients. So 6 over 2 times x to the 9 minus 1. Remember, this is an invisible 1 exponent. Then we have our base of y. So y to the 4 minus 2. And lastly, our base of z. So z to the 5 minus 4. So then our final answer, go back to red. 6 divided by 2 is 3. And then we're left with 8 total factors of x, 2 total factors of y. Sorry, this is a 4. And 1 total factor of z. On the next page, I have a few more quotients for you. Notice the quotients inside of the parentheses are not like bases for any of these examples, so nothing can be simplified. However, we do have an outer exponent, and all I wanted to show you is that this exponent applies to both the numerator and the denominator. So 2/3 to the 3rd power is the same as 2 to the 3rd divided by 3 to the 3rd. So then x divided by y to the 3rd power becomes x to the 3rd divided by y to the 3rd. And then we can actually apply the power rule in this third example. So 2x to the 3rd becomes 2 to the 3rd, x to the 3rd, and then y squared to the 3rd becomes y to the 6th, because remember, we're multiplying those exponents. In these next few, I just want to remind you of order of operations. We call it GEMDAS this year. The G represents grouping, E is exponents, M and D are multiplication and division, A and S are addition and subtraction. When you think about order of operations, this is a way to remember what you're doing with the exponents based on the original operation. So notice in this first example, we are multiplying like bases. So that tells us that we are adding the exponents of the like bases. So remember, we're multiplying 5 by 6, so that's 30. But then y cubed times y to the 7th becomes y to the 10th, since 3 plus 7 is 10. In the second example, the main operation is an exponent, so we are multiplying those exponents. As a reminder, the 4 does have an invisible exponent of 1, so this becomes 4 to the 4th power, since 1 times 4 is 4, x to the 20th power, since 5 times 4 is 20, and y to the 12th power. And in the third example, the operation we're focusing on between the like bases is division. So when we're dividing like bases, we subtract the exponents. Now, our coefficients are just regularly divided. 5 divided by 7 does not get simplified. You could write it as a decimal or leave it as a fraction. A to the 8th divided by a to the 5th becomes a to the 3rd, since 8 minus 5 is 3. And b to the 5th divided by b to the 3rd becomes b squared, since 5 minus 3 is 2. Lastly, we can complete a combination of multiplication, power, and division, or I could say the product rule, the power rule, and the quotient rule. Now, according to order of operations, the power rule should be applied first. So notice that would occur with this expression right here. We must use the power rule. So this becomes, so notice I wrote 8. Remember, that's just 2 to the 3rd power. And that was 2 to the 3rd because of this invisible 1 exponent. And then a to the 9th power and b to the 12th power. So since I had power to a power, I do multiply the exponents. Next, I could do multiplication or division, or aka the product or the quotient rule. However, it's going to be easiest, in my opinion, to apply the product rule first. So you'll notice that means I'm applying that to this expression right here. And when I'm multiplying like bases, I'm adding the exponents. So my new numerator, first of all, I've got 8 times 4, so that's 32. And then a to the 9th times a, so that's a total of 10 factors of a. B to the 12th times b to the 5th is 17 total factors of b. And then my denominator did not change yet. So lastly, I'm going to apply the quotient rule. So I'm dividing like bases, and as we know, that means I'm subtracting the exponents. Now, looking at 32 divided by 64 first, remember, we're not dealing with exponents here, so we simply just divide. Well, 32 divided by 64 is 1/2, or I could write 0.5. And then a to the 10th divided by a to the 5th is a to the 5th. Remember, I'm subtracting the exponents. And b to the 17th divided by b to the 3rd is b to the 14th. So in the end, we started with this large exponential expression and simplified it using all 3 rules, product, power, and quotient rules, to simplify to this simpler, much simpler expression. Make sure you're taking your time and referencing these notes as you complete the practice questions for section 6.2. These will be graded on completion this week, and I will be checking them in class next Monday.